This soil used to grow almost nothing. Plants struggled, harvests were weak, and no amount of watering seemed to help. I didn't bring in expensive fertilizer or replace the soil. Instead, I planted a few specific plants and let them do the work. What happened over time completely changed how productive this garden became. When people talk about improving soil, they usually focus on what to add: compost, fertilizer, amendments, minerals. But soil can also be improved by what you grow in it. Certain plants don't just survive in poor soil, they actively change it. They loosen it, feed it, protect it, and slowly turn it into something that can support real harvests. This is the story of how plants themselves turned poor soil into productive garden beds. Most poor soil problems share the same symptoms. The ground is compacted, dry on the surface but hard underneath, low in organic matter, and unable to hold nutrients. Water either runs off or drains too quickly. Roots struggle to penetrate, and microbes have little reason to stay. When vegetables are planted directly into this kind of soil, they fail not because of the gardener, but because the soil system itself is broken. One of the most powerful ways to begin repairing poor soil is by growing deep-rooted plants. These plants act like living tools, pushing roots down into compacted layers that human tools often can't reach effectively. As these roots grow, they create channels that allow air, water, and microorganisms to move more freely through the soil. When the plants die back or are cut, those root channels remain, slowly transforming hard ground into soil that can breathe. Plants like daikon radish, forage radish, and certain types of turnips are especially effective at this. Their roots grow fast and aggressively, breaking through dense soil layers. Over time, these roots decompose underground, leaving behind organic matter exactly where the soil needs it most. This process improves structure from the inside rather than just dressing the surface. Another category of plants that dramatically improve soil are nitrogen fixers. These plants form partnerships with beneficial bacteria that live in nodules on their roots. The bacteria pull nitrogen from the air and convert it into a form plants can use. This natural process enriches the soil without synthetic fertilizers and creates long-term fertility rather than a temporary boost. Legumes such as clover, peas, beans, vetch, and lupines are some of the most well-known nitrogen-fixing plants. When grown regularly in poor soil, they gradually increase nitrogen availability not just for themselves, but for future crops. The key is that the nitrogen remains in the soil when the plant is cut back or its roots decompose. This is slow, steady enrichment rather than instant feeding. Ground cover plants also play a critical role in transforming poor soil. Bare soil is vulnerable soil. It dries out, erodes, overheats, and loses life quickly. Ground cover plants protect the soil surface, regulate temperature, reduce moisture loss, and provide a steady supply of organic material as leaves die back and regrow. Plants like creeping clover, sweet potato vines, squash, and low-growing herbs shield the soil while actively feeding it. Their constant leaf drop becomes mulch. Their roots support microbial life. Over time, soil that was once exposed and lifeless begins to darken, soften, and hold moisture more effectively. Some plants improve soil simply by producing large amounts of biomass. These plants grow quickly, generate a lot of leaf and stem material, and can be cut back repeatedly. Each time they are cut, the material can be left on the soil surface as mulch or lightly incorporated. This adds carbon, feeds microorganisms, and increases organic matter. Plants like comfrey, sunflowers, sorghum, and certain grasses are especially effective biomass producers. Comfrey, in particular, has deep roots that pull minerals from lower soil layers and store them in its leaves. When those leaves are cut and returned to the soil, those nutrients are redistributed to the root zone of other plants. Living roots are one of the most overlooked aspects of soil health. Soil that always has something growing in it stays alive. Microorganisms depend on sugars released by roots, known as root exudates. These exudates feed bacteria and fungi that in turn make nutrients available to plants. When soil is left bare, this entire system slows down or collapses. By rotating or interplanting soil-building plants, the soil remains biologically active year-round. Even when food crops are not growing, cover plants keep the underground ecosystem functioning. This continuous activity is what gradually converts poor soil into productive soil without drastic intervention. Some plants also improve soil by stabilizing nutrients that would otherwise be lost. Fast-growing plants absorb excess nutrients and store them in their tissues, preventing leaching. When these plants are later cut or die back, the nutrients are released slowly, making them available again at the right time. Plants like ryegrass, buckwheat, and oats are often used this way. Buckwheat, for example, grows quickly in poor soil and is especially good at mobilizing phosphorus, a nutrient that is often present but unavailable in compacted or depleted ground. When buckwheat is cut before seeding, it releases that phosphorus back into the soil. Over time, these plant-based improvements begin to compound. Soil texture improves, earthworms appear, water infiltration increases. Plants stop struggling and start growing normally. What once required constant inputs becomes easier to manage. The garden starts to work with you instead of against you. One of the most important lessons from using plants to improve soil is patience. This is not an overnight transformation. Poor soil that developed over years will not heal in a single season, but each planting cycle builds on the last. Each root, leaf, and decomposition cycle adds another layer of improvement. The biggest shift is mental. Instead of seeing soil as something that must be fixed before planting, it becomes something that improves through planting. Even food crops can be chosen strategically to support soil health while providing harvests. Beans enrich nitrogen. Squash covers soil. Sunflowers loosen structure. The garden becomes a system rather than a collection of separate plants. Eventually, the need for external fertilizers decreases. Compost becomes a supplement instead of a requirement. Watering becomes more efficient. Plants become more resilient to stress. The soil itself begins to buffer mistakes, weather extremes, and irregular care. This approach is especially valuable for home gardeners working with poor native soil, compacted ground, or neglected land. Instead of hauling in soil or relying on constant inputs, they can let plants do what they evolved to do: build soil, protect it, feed it, restore it. The most productive garden beds are rarely created all at once. They are built slowly by roots pushing down, leaves falling, microbes multiplying, and plants working quietly below the surface. When you choose the right plants, even poor soil can become fertile again. What became most clear over time was that soil does not become productive through force, additives, or constant correction, but through relationships that are allowed to develop naturally between plants, microorganisms, and organic matter. These plants did not fix the soil overnight, and they did not rely on external fertilizers to perform their work. Instead, they operated slowly and quietly, adding roots where there were none before, releasing organic compounds that fed soil life, and creating pathways for air and water to move through ground that had once been compacted and lifeless. As their roots grew, died back, and regrew again, they left behind channels that loosened the soil from within, something no tool or machine could do as effectively. Fallen leaves and pruned material returned to the surface, breaking down gradually and forming a natural mulch that protected the soil from erosion and temperature extremes. Over time, earthworms appeared where there had been none, followed by fungi and bacteria that transformed raw organic material into stable nutrients plants could actually use. What looked like poor soil at the beginning was not empty or broken, only dormant, waiting for the right conditions to wake it up. These plants provided those conditions simply by growing and being left undisturbed long enough to do their work. The result was not just healthier soil for themselves, but soil that became capable of supporting other crops with far less effort. Seeds germinated more easily, moisture stayed in the ground longer, and plants that once struggled began to grow with less intervention. This shift changes how a garden is managed, because once soil starts working with you instead of against you, the entire system becomes more forgiving. Mistakes matter less, weather extremes become easier to handle, and the need for constant inputs fades into the background. Instead of asking what the soil lacks, the focus shifts to what the soil is already capable of producing when it is protected and fed in natural ways. These plants demonstrate that fertility is not something that must always be purchased or applied, but something that can be built and maintained through thoughtful planting and patience. In the long run, they offer a more stable, resilient foundation for food production than any quick solution ever could. By letting plants do what they have evolved to do, the garden becomes less about control and more about cooperation, and the soil transforms from a problem to be solved into a living system that continues to improve year after year. In the end, soil improvement isn't about control. It's about cooperation. The plants that turned this poor soil into productive garden beds didn't do it through force. They did it by being planted, allowed to grow, and allowed to complete their role in the system. That's the power of letting plants build the garden for you.